Yes, welcome back dear students. In today's video, I am going to discuss some of the problems on star to delta or delta to star transformation. As we have discussed in previous video, say star is nothing but star network is also called as Y network or T network, and delta network is also called as pi network. Okay, say even we can call this as a Y or T to delta or pi transformation. Okay, say without wasting too much time, let us start with the first problem on delta to Y transformation. So the problem statement is convert delta networks shown in figure 1.1 to equivalent Y or T networks. Say if you see dear students, here we have two delta networks, one say in figure 1.1 A and another one in figure 1.1 B. Okay, so these are very simple problems where we are going to learn, through these problems we are going to learn how to convert a given delta network to a say equivalent T network or Y network. Let us start with the solution. Yes, solution. So here we can see dear students, there are 3 resistors in a delta network. Okay, say here these two, say you can see this as a pi network. Even say if you connect these two terminals at a single point, then you can see that as a delta network, right? Say what I do here initially, say referring to this, first I will convert this to equivalent T network. Referring to this, what we do, say I will redraw this for your convenience to convert it to a equivalent T network. Say there is a 17 ohm resistor in between A, B, and there is 33 ohm resistor in between D, and there is 20 ohm resistor, 21 ohm resistor in between BD. Say this is 33 ohm and this is 17 ohm, right? Say what we do, this network has to be converted to equivalent Y or T network. How do I convert? So this point, this and this both are same point only. Instead of telling C and D, we can just tell it as a C only, doesn't make any difference. Say here I am going to convert this to a equivalent Y network. Say this dashed line indicates I am converting this network. That's the meaning, means equivalent of this network, right? Say here let me call this as a R1, this as R2 and this as R3, resistor R3, right? So and even say for your convenience what I do, this 17 ohm resistor I call it as a, say for example this I start with this, RA is 33 ohm, RB is 17 ohm and this RC is 21 ohm. Okay, say now we need to convert from delta to Y network. So conversion formula to convert resistor from delta to Y network, say we have a conversion formula, like say for example R1 is equal to, say if you want I will just remind, say repeat means I will just make you to recall what are the formula for converting a given delta network to a Y network. Now see, this is RA, this is RB, this is RC, and let us consider I am converting this to a equivalent Y network. Say now this is a Y or T network, where I am calling this as say R1, this as R2 and this as R3. In such case, any network, say for example R1 is equal to, say what is the formula, say here two nearest resistors, okay, multiply these two nearest resistor, say which is RA RB divided by sum of all the resistors, that's nothing but RA plus RB plus RC, right? So and this is equal to, now so let us substitute the values, say RA is 33 ohm 33 into RB is 17 ohm divided by RA plus RB plus RC, that is 33 plus 17 plus 21, say which is equal to, say let me take calculator and calculate this, right. Say 33 into 17 is equal to, say it is 561 divided by 33 plus 17 plus 21 is equal to, say it is 71, right. And say this everything is equal to, means R1 is finally is equal to 561 divided by 71, right. Say 561 divided by 71, say how much we get, let us see, is equal to, say it is 7.9 ohm. 7.9 ohm is value of R1, right. And similarly, I can write R2, I can find R2. R2 is equal to, see dear students, R2 is this network, okay. Say two nearest resistance means RB and RC, okay. Say RB RC divided by, say for all the denominator, for all the resistors R1 R2 R3, this denominator remains same, RA plus RB plus RC. Because of that, say this I make it D, like say D, where, so next onwards I will consider this denominator all the time. D is equal to RA plus RB plus RC, and this is equal to, say how much is this, 71 ohm. Therefore, say R2 is equal to, say RB is how much, if you see here RB is 17 ohm into, say RC is 21 ohm divided by, say this is 71 ohm, and this it is equal to, if we calculate how much we get, so let us see, say it is here 17 to 21, right, divided by 71, so it is 5.028, it is 5.028, right. And finally, say R3, we are supposed to find R3, R3 is equal to, right. Say if you see this network, dear students, R3 is this network, this resistor, two nearest resistors means RA and RC. Here R3 is equal to RA RC divided by D. D is nothing but denominator. Say that is RA is how much, 33 ohm into RC is 21 ohm divided by D is 71. How much we get? So let us calculate this. It is 33 into 21 divided by 71 is equal to, say it is 9.76 ohm, that is R3. Now between A, B, C, D, the given network, whatever the network is given, that network can be read. So I will redraw the given network between A, B, C, D. This is point A, say this is point B, and here say point C. Say here, say CD, I will directly join this, and here this is one resistor, this is another resistor, and this one is third resistor. And as per our conversion, what we have taken, R1 is this and R2 is this, R3 is this, right. So R1 value is 7.9 ohm, R2 value is 5.028 ohm, and R3 value is 9.76 ohm. So this is a simple conversion, dear students. I explained this in detail, okay. Say given any delta or pi network, it should be converted to a, say if at all we want to convert that to a T network, which is also called as a Y network, okay. Say for that purpose we should use a conversion formula which we have derived in previous video, right. Say and so using conversion formula directly we can find the equivalent resistors in case of converted T or Y network, okay. Same thing we will do for the second network also. The second network is, this is the second network. Let me take this network, this is network B. For this, say here we have, this is A B, this is sorry A C, no problem, A B, this is C D, no, So this is A, B and C, D, right? Here one resistor, it looks like a pi network, no problem, pi or delta both one and same. This is 2.1 kilo ohm, here 1.1 kilo ohm, and this is 4.7 kilo ohm, right? So now directly I will convert this to a equivalent Y network. How do I convert? Here itself, so I will write, okay, say here if I take up this point, here one resistor will get, and here another one is this. So let me call here resistance as R1, R2 and this is R3, right? So as usual, R1 is equal to 2 nearest resistance, this is 1.1k into this is 4.7k divided by all the resistors. Say here, before that here I can write, like say for example here I will write let D is equal to RA plus RB plus RC, and means I call this as RA, RB, RC. So if I add all, like say for example if D is equal to RA plus RB plus RC, that is 1.1k plus 4.7k plus 2.1k is equal to, let me add how much we get, 1.1 plus 4.7 plus denominator 7.9k. R1 is equal to, say let me calculate this, 1.1k divide into 4.7k divided by 7.9k is equal to, it is 654.43 ohm is the value of R1, right? Similarly, say I will find R2. R2 is equal to, now two nearest resistance, R2 is this, one is 4.7 and another one is 2.1, 4.7k into 2.1k divided by that D is 7.9k, which is equal to, so now if you calculate this, 4.7k into 2.1 divided by 7.9k is equal to, it is 1.249, right? So it is 1.249 kilo ohm is R2, very simple, okay. Similarly, so we can find R3 also, okay, where R3 is equal to two nearest resistance means 2.1k and 1.1k. Here 1.1k into 2.1k divided by say all three, that is nothing but D, which is 7.9k, and this is equal to, so let me calculate. So if I calculate this, it turns to be, say how much, let me show here, okay. So it is 1.1k into 2.1k divided by 7.9k is equal to, say it is 292.4 ohm is the value of R3. So between A, B, C, D points, this is A, this is C, and here B, and this point I consider it as D. Say CD I will directly connect, and this point, say we have a T or Y network, right? So this is one resistor, this is another resistor, and this is the third one, where this is R1, this is R2 and this is R3. R1 is 654.43 ohm, R2 is 1.249 kilo ohm, and R2 is 1.249 kilo ohm, and R3 is 292.4 ohm. Hope this is clear to all of you. So what we have done in this particular numerical, we have converted given delta or pi network or T network. We will take up one more numerical where say we will convert a given T network to a equivalent delta net. Say I will take up this one numerical where say a given delta network will be converted, T network will be converted. Okay, say this I'll take it as a second one, right? Second numerical converting a given network. Okay, say if at all you want statement, I'll write convert given T or Y networks to equivalent delta or pi, both one and same networks. Okay, so with that first one I'll consider a T network. Obviously there will be 3 resistors. This is a given T network, let's say A, B, this is C, right? Say this one I call it as R1, this as R2, say this as R3, and the value of resistors, let me take same, this is 33 ohm, this is 21 ohm, and R3 is say for example 17 ohm. And one more let us take, say one more is, say I'll write this in terms of Y network only. So this is A and B, say below we'll get this is C, D, and this network, okay, and this third one resistor, and I call this as R1, this as R2, and this as R3. R1 is, the value of R1 is 1.3 K, means 3 kilo ohm, 1.3 kilo ohm. This is 2.1 kilo ohm, and R3 is, right? Say this I call it as a figure A, this is figure B. Say let me take this as a figure 2. Okay, to say 2.1, say 2.1 AB. First let me take up first network and convert it. Start the solution. First network is, it is simple, I'll redraw it. There are 3 resistors in a T network. Right, so this is A, B, C, D. I just write R1, R2, R3. This network has to be converted to a equivalent delta network. How do I convert? Look at this. Here we will get one resistor between these two, and here we will get one more resistor, and third one is between AB. So I'll draw like this. This is third resistor, and let me call this as resistance RA, this as resistance RB, and this as resistance RC. Okay. Now to convert given delta network, T network or Y network to a delta network, say we have a conversion formula where, say for example, so I will make you to recall, consider that this is a given T network R1, R2 and R3, and I want to convert this to a equivalent delta network, right? And one more will be here, same thing. So where this is RA, RB, and this one is RC. Now RA is equal to, so we can write RA is equal to, how do we write? RA is, it will going to connect two resistors. It has been connected to 2 resistors directly. One is R1 and another one is R2. Both are connected to RA. Means it, you can remember this something like this: R1 plus R3, the 2 resistors which are connected to RA, R1 plus R3, plus of R1 R3 divided by the resistor which is not connected, that is R2, and which is equal to, so this is equal to, say how do I write? R1 is how much? Say R1 is 33 plus of R3 is 17 plus of 33 into 17 divided by R2 is 21, right? And this is equal to, say let us calculate this. Say this is 33 plus 17 plus 33 into 17 divided by 21 is equal to, say it is 7.86. It is 76 point, how much? 71, yes, 76.7 ohm, 71 ohm is R1, right? Sorry, RA. Then RB is equal to, more, say formula for this is something like this: R1 R2 plus R2 R3 plus R1 R3 divided by, say RB, say R1 R2 R2 R3 plus R1 R3 divided by the resistance which is not connected to RB. RB is, say, for which resistor? Say for example here if you take RB, say R3 is not connected, right? So if you take RB, say R1 R2 both are not connected, R3 is not connected, something like this. If you see R3 here, R3, it will get cancelled, you will get R1 R2, means even this itself we can write something like this. How? R1 plus R2 plus R1 R2 divided by R3. Either you remember this or you remember this. If you remember this, you can compute this only once, R1 R2 plus R2 R3 plus R1 R3, you can compute this once, divided by, say here R2, say for whole divided by R2, here whole divided by R3, and for RC you will get whole divided by R1, right? So however you wish, say anyways I have written like this. Here R1 is how much? R1 is 33 ohm plus R2 is 21 ohm plus 33 into 21 divided by, yes, let me calculate this. It is 33 plus 21 plus 33 into 21 divided by 7. Ohm is RB. Right, dear students, this is the value of RB, and finally, so we can calculate RC. RC is equal to, so now if you see this, RC is the two resistors which are connected to it is R2 plus R3 plus of R2 R3 divided by the resistance which is not connected is R1. R2 is how much? R2 is 21 plus R3 is 17 plus 21 into 17 divided by the resistance which is not connected is 33, right? So this is equal to, so let me calculate, it is 21 plus 17 plus 21 into 17 divided by 33 is equal to, it is 48.818 ohm, that is RC. So very simple, dear students, and the equivalent network you can draw here between 4 points. Those are, say 4 points are, one is A, another one is B, here C, and here it is D. Between these 4 points, given T network should be converted to a delta. Okay, say here delta or Y, delta or pi network. I will do this. Here you have one resistor, here the second, and here the third one, and this is RA, this is RB, and this is RC, right? And even the value of resistors, RA is 76.71 ohm, RB is, it is 94.765 ohm, and RC is 48.818 ohm, right? So this is how you can convert a given T or Y network to a equivalent delta network. Say one more is there. Say after converting that, we can take up some other numericals. Okay, this is very simple. Say where B, say this is B1, given network is like this, right? Say this is A, C, this is B and this is D. Here this is 4.7 kilo ohm, and here you have one resistor and here you have another resistor. Okay, say the value of this is 1.3 K and this is 2.1 K, and the resistance R1, R2 and R3. Here itself I will make a delta. Say for example delta network, if I make, say between these two you will get one resistor, second one, and here you will get the third, right? Say I call this as R1 or say RA, RB, this is RC, right? So let me solve this. Okay, so whatever the network given, say one is, say very simple. Say one more method what I do, so I will take that numerator is equal to R1 R2 plus R2 R3 plus R3 R1, which is equal to say 1.3 K into, next is R1 is 4.7, okay, one is say 4.7 K and plus of R2 1.3 K into 2.1 K plus of 2.1 K into 4.7 K. So once you can calculate this, another method I am just telling you people to remember. Say this is R1 R2, say we are calculating this numerator. Okay, so let me calculate 1.3 K into 4.7 K plus of 1.3 K into 2.1 K plus of 2.1 K into 4.7 K, right? So is equal to, so how much is this? It is 18.71 mega ohm. So this turns to be 18.71 mega ohm. So I have calculated N. So you can write something like this, let N is equal to, okay. Now to find R1, RA is equal to, what is the, see RA is this, the two resistors which are connected is R1 R2 and the resistance which is not connected is R3. That means I can write this as N by R3, which is equal to, because this resistance is not connected. So N is already known to me, 18.71 mega ohm divided by the value of R3 is 2.1 kilo ohm, and RA is equal to, say this is already N is there, okay, say divided by, say it is not 2.1 kilo ohm, okay, 2.1 kilo ohm, say divided by 2.1 K is equal to, it is 8.91 kilo ohm is RA, right? Similarly, say you can calculate R2, not R2, RB is equal to, say look at dear students, RB, this is the resistance RB, to this, these two resistors are connected, R2, R3, the resistance which is not connected is R1, that means it is N by R1, which is equal to 18.71 mega ohm divided by R1 is 4.7 kilo ohm, and RB is equal to, yes it is, let me calculate, 18.71 mega divided by 4.7 kilo is equal to, it is 3.98 kilo ohm, 3.98 kilo ohm RB. And similarly, say now RC is equal to, look at dear students, this is resistor RC, to this R1 R3 are connected, whereas R2 is not connected. That means I can write RC is equal to N by R2, which is equal to 18.71 mega ohm divided by R2 is 1.3 kilo ohm, and RC is equal to, yes, how much we get? Say it is equal to yes, it is equal to 18.71 mega divided by 1.3 kilo is equal to, yes, it is 14.39 kilo ohm is the value of RC, right. Now, see, we can draw the network between 4 terminals A, B, and say this is C, D. I will draw this like a delta network is itself, something like this. Even this is no problem. You can draw like this, where you have the equivalent, find the equivalent resistance R in for the network shown in figure say 3.1. Let me draw that figure. Say here we have resistor, okay, so this is between these two terminals we should find R in input resistance, and here one more resistor, here we have another resistor, here one more, here one more, here another, and the last resistor is here, right. And this is R, this is R, this is R, 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 this is R, this is R, and this is R, and the value of R is equal to 2.2 kilo ohm, and this is the figure 3.1, right. So let us calculate, means we should find or calculate the equivalent resistance between these two terminals. So you may name these two terminals like A and B if at all you want. Between A, B, whatever the resistance, it's been given R in, you are supposed to find the value of R in for the network of this figure, okay, where all our all resistors are equal to R, and R is equal to 2.2 kilo ohm. Now dear students, this given network itself I will start converting. So let me write solution. Okay, say what I do, say dear students, there are different methods to convert a given network to a equivalent, means we can convert a given network to a equivalent network using delta or Y transformation. He has not given anything, but there are no other options, there is no other option other than using a delta to Y conversion, because no resistors are in series or none of the resistors are in parallel here, okay. You can see all delta networks or say some T networks, okay, T delta network combination is there. So because of that he has not told anything, find the equivalent resistance R in for the network. So obviously we should use delta and Y transformation. Even there are other methods to use, but will rely as of on delta to Y transformation, because even he hasn't given any sources also, okay. So what I do, I am going to use delta Y conversion to solve this, right. Say initially what I do, there is a T network this, and dear students, there are different methods to solve this. What I do, say I am going to tell one or two methods, say for this network only. Instead of discussing many problems, I will discuss this particular network in a different methods, okay. Say first, say I call this as a, say for example method 1, nothing like a fixed method, just whatever the way I am solving, that I call it as a method 1, nothing other than that, okay. It's not a method 1, method 2, method 3, whatever I am calling, no, so I means whatever I am solving, no, that I call it as a method 1, right. So in this method what I do, initially I am going to convert this given T network. Inside this you can see there is a T network, 1 2 3. This network I will convert to a delta network like this. Say here and this one, right? Okay, and I call this resistance as R1, this R2, this as R3, right? Means these three R will be converted to R1, R2, R3. And yes students, say if we want to convert this, converting even I'll write here converting a Y or T network of figure 3.1 to equivalent delta network. Okay, say what we get, we want to find R1. Now R1 is equal to, look at the students, to convert a given delta to Y, say as I told, sorry, T to delta, as I told, two resistors which are connected to it is, one is R, another one is R, say it is R plus R, and the resistor say which is not connected is also R, it is R into R divided by R, nothing but R plus R plus R, because R will get cancelled, is equal to 3R. Dear students, here you can understand one thing, where if the value of all three resistors in a given T network are equal, then when we convert that to a delta network, that particular resistance will be 3 times greater than the resistance in a T or Y network, because in a T network the resistance, value of resistance is R, whereas delta network the value of resistance is 3R, right? Similarly for R2 also we will get 3R, and even if you calculate R3, that also will get 3R. R1 is equal to R2 is equal to R3 is equal to 3R is equal to 3 into R is 2.0 kilo ohm, say nothing but which is equal to 6.6 kilo ohm, right? So this is the value of R1, R2 and even R3, right? Now what I do, say I will redraw this network, this particular network, so I will redraw, eliminating this T network, right? So let me redraw it here itself. If you see, say this, there is a R resistor, here there is a R resistor, I don't touch them. Here we are supposed to find R in R and R, and here above one R resistor is there, even below also there is a R resistor, and this also have not touched. Okay, so anyhow, say this will consider later. And here dear students, before we proceed further, you can see here R3 and R, the converted R3 and this R, both are in parallel. Okay, so what I do here itself, before I draw this, I'll write let R4 is equal to R3 parallel R. Okay, because this is R3 and this is R, this is how much, 6.6 kilo ohm parallel with 2.2 kilo ohm, right? So and this R4 will be equal to, say how much we get, so it is 2.2k into 6.6k divided by 2.2k plus 6.6k is equal to, yes, it is 1650 ohm is the R4. R4 value is 1650 ohm. Now particular R4, these two resistors are converted to a single resistance, so its value is R4, means here that resistance I call it as R4, and this is as it is R, this is as it is R, this is R4, this resistance and this resistance, 3 resistance have taken out, and this one from here to this we have R1, and from here to here, so we have R2, this is R2, right? So now So very important, dear students, this network has to be converted further. What I do, because here we have one delta network, here another delta network, I simply convert a given these two delta network to a equivalent. For this figure I call it as a figure 3.2, right? Now converting given converting network converting delta network formed by R and R1, also R and R2 to equivalent which networks? Y or T network, T or Y networks, right? So now converting delta networks formed by R1 also R2 to equivalent T or Y networks as shown in figure 3.3, right? So let me draw that figure. Okay, say here itself, even if you want I can change, but let me draw it. Okay, say once again I'll draw it, right? Say here we are supposed to find R in, okay, and now this is R, we have another R above, below another R, this one is R and this one is R, right? And here we have R4, and what I do, this and this, even I can directly connect here. So this, whatever the resistance it's been connected, even I can connect here also, right? Say here one and another one is like this, right? Say this is R1 and this one is R2. Now this network, these two delta I will convert to a equivalent Y. One resistor will get here, another one will get here, and the third one is here. Similarly here also, one is here, third one is here, second one and third one. So I'll name these resistors, like say here R5, R6, R7, similarly R8, R9 and R10, and this figure I call it as figure 3.3. So very simple, dear students. Here this delta network and this delta network I am converting to equivalent T networks, and before I redraw and remove remaining say these delta resistors, I am going to find the value of delta resistances. Okay, so let not delta resistances, T resistances. Okay, so let me start. First we will find R5. R5 is equal to, yes, what is R5? Now if you see, R5 is equal to, say here, so as I told, it is this resistance into this, we are converting delta to T network, say two resistance multiply two resistance adjacent to it, means the resistance connected or adjacent to it. So to R5, these two resistors are connected, or you can say adjacent. Okay, say these two resistors, right? R and R. I'll write R into R divided by all the resistors that I call it as a D, and where here itself I'll write where D is equal to, it is R plus this resistance, this is R1, right? This resistance is R1, so it is R plus R1, where even D I will write R is 2.2 K plus one more R is 2.2k plus, say this is R1 is 6.6 kilo ohm, and which is equal to, this is 11 kilo ohm is D, right. Now onwards I use this D directly everywhere. So this is equal to R into R, that is 2.2k into 2.2k divided by 11k, and R5 is equal to, so let me calculate, dear students. This R5 is 2.2k into 2.2k divided by 11k is equal to, it is, just a minute, it's 11k, right? Yes, 2.2k into 2k divided by 11k is equal to 440 ohm. R5 is 440 ohm. Similarly, now R6 is equal to, R6 is this resistor, you can see here. R6 is two resistors which are adjacent, is one is R into R1, this and this resistance, okay. So R into R1 divided by D, which is equal to, say here R is 2.2k into R1 is 6.6k divided by 11k, right, and this is equal to, now 2.2k into 6.6k divided by k is equal to 1320 kilo, this is ohm, not kilo, ohm, right. Now say R7 is equal to, R7 is this resistor, two resistances, one is R, another one is R1, right, this and this, R into R1 divided by D, right, and this is equal to, so obviously this will be same as above, which is 1320 ohm, right, and now R8 is equal to, so R8 is this resistor, this, and two resistance which are adjacent to it are R and R2, R into R2 divided by D. Here also, dear students, where D is, here in this case where D is equal to, three resistors are R, and another one is R2, R plus R2, and if you calculate this also, we will get is equal to, say 11 kilo ohm only, because R2 is 6.6 and these two are 2.2, okay, so in terms of kilo ohm. Now R8 is equal to, say R is 2.2k into R2 is 6.6k divided by 11k is equal to, R8 is, it is 1320 ohm, and R9 is equal to, say R9 is this resistor, two resistors which are adjacent is R2 and R, R2R divided by D, which is also you will get equal to 1320 ohm, and lastly R10 is equal to, so if you see this resistor R10, two resistors are R into R, so R divided by D, which is equal to, say this you will get equal to 440, if you calculate, say you will get equal to 440 ohm, right. So we have found, say R5, R6, R7 and R8, R9, R10 of T networks, resistors of T networks. Now if I redraw this, dear students, if you see, I can redraw this by removing the resistors of delta network. How I redraw? Let us see. Here this and this as it is, one is R and another one is this R, say R in as it is, okay, so this is R and this is R. Now this R4 also have not done anything, I will keep as it is. Here you have R4, later I will consider it, say we have not done anything to it, but this resistance, this these are not there. Okay, say instead of these resistors what we have, okay, sorry dear students, I will just redraw it once again. Here you can see this resistor both are not there. Okay, I will start with this. Okay, so which are the resistors? Say here this not there. First is R5, the first resistor what we get is R5, and now this R5 and this R7 I will draw like this. This is R5, this is R7, and between this here one more resistor is connected, that is R6. This is a converted T network or Y network, whatever. And now to this point, say which are the two resistors? One resistor connected is R8, and this and both resistors will be taken out because they belongs to delta network. So one is R8, and to this network, to this resistor R10 is connected, another one is R10, right. So this is R8, this is R10, and here Rin is between these two terminals, right. And now here between R8 and R10 what is connected? R9 is connected, this is R9, right. And now these two resistors will go directly. This R6 is connected to R4, and this is R6 and this is R9, another end is connected to this R4, this is R4. So hope this is clear to you dear students. I have removed all resistors of delta network and redrawn the remaining resistors. Okay, so this is say for example I call this as a figure 3.4, right. And if you see this figure dear students, it is very easier to calculate Rin from this figure. Let me show you that. Now if you see these three resistors R6, R4 and R9 are in series, and even these two resistors are in series. Even if you want I can directly calculate this resistor, but I will go one more step to reduce this. Let R11 is equal to R7 plus R8, because these two resistors are in series. R7 is equal to 1320 plus R8 is also equal to 1320, which is equal to, it is 1320 plus 1320, nothing but 1320 plus 1320 is equal to 2640 ohm, right. And R12 is equal to, say here R6, R4 and another one is R9, all are in series, R6 plus R4 plus R9, which is equal to, R6 is how much? It is 1320 ohm plus R4 is, so the value of the resistor R4, the value of resistor R4 is, let me see that how much it is, where I wrote, yes, the R4 value here we have found dear students, it is 1650, right. So R4 is equal to 1650 ohm, right. So this is 1650 plus of R9, R9 is 1320, which is equal to, say here, so it is 1320 plus 1320 yes, plus of 1650 is equal to 4290 ohm is R12. Now redrawing this figure, network of figure 3.4, so you can write something like this. Now redrawing redrawing network of figure 3.4. so this is the figure 3.4. okay, where I can reduce these 3 resistors to a single resistance and these 2 resistors to a single resistance. If I redraw it, so how we get? Here you have only one resistor, here another, here third one, R in, this is R5, this is R10. Now R7 and R8 both are say reduced to R11, and parallel with this we have R12, which is a combination of these 3 resistors R6, R4 and R9. okay, so now say Rin is very straightforward. Rin is equal to, okay, this I call it as a 3.5, figure 3.5. so this is figure 3.5. now redrawing the network of figure 3.4, so you can write as shown in figure 3.5, something like this, right. Rin is equal to, now it is very straightforward, R5 plus R11 parallel to R12 plus of R10, which is equal to R5 is 440 ohm plus of R11 is, yes, R11 here is, it is 2640 parallel with 4290 and plus R10 is, yes, R10 is 440 ohm, which is equal to, this is 440 ohm plus of, say this is parallel combination, let me calculate, 2640 into 4290 divided by 2640 plus of 4290 is equal to, it is 1634.28, so this I call it as 6, right, plus of 440, and this is equal to, say plus 880 if I add, so we will get 2514.286 ohm is the value of Rin. So this is Rin. Hope this is clear to all of you, dear students, right. This is actually a simple one method. One method means what, why I call this as a one method, because we have option here to convert a network, say this network, like say we started with conversion of this T network. Where is hard and fast rule? I can start with the conversion of this delta network, say for example this is the delta network, R to convert it to a equivalent T network. What I do, so I will solve this in another method. Okay, so one more method I will show you, where I am going to convert a different, say for example instead of converting this T network, I am going to convert this delta network to equivalent T network. So I will solve in that way. Okay, instead of taking a, say another numerical, I am going to solve this particular network itself in a different way. Okay, say first I will redraw this network, dear students. This I call it as, say for example method 2, means in a different method I am solving this, because of that I call this as a method 2, right. Before that, let me draw the given network. We have 2 resistors R and R here, Rin is here, this is R, this is R, and one resistor is here, another one is here, third one is here, and here one more resistor, here one more resistor, and this is another last resistor. All resistor values are same, R, and R value is 2.2 kilo ohm. Say we already know R is equal to 2.2 kilo ohm, and this I call it as a figure. Say for example, say I may continue the figure numbers. I don't know where I had stopped. I continue this to figure. Say for example 3. Mostly say 7 or 6, whatever. Say I will call this as a 3.7, figure 3.7, right? What I do, say in previous method we started converting this T network, whereas here we have a delta network. Look at dear students, these 3 resistors will form a delta network. What I do, I will convert these 3 resistors to equivalent T network like this. One resistor I will get this, and another I get here, and the third one is here, right? So, and I call all 3 resistors like, say this is R1, this is R2, this is R3, okay. And now if I want to find, now R1 is equal to, because we are converting a given network to equivalent T network or Y network. See, it is 2 resistors which are connected, like say R1 is this, 2 resistors which are connected to it are R and R, okay. These 2 are connected, say R into R divided by all the sum of all 3 resistors, R plus R plus R, which is nothing but this is R into R divided by 3R, and say this is equal to R by 3. So, that is what, dear students, I told when we were converting from delta to equivalent, so T to the equivalent delta network, we got R1 is equal to 3R, right? But now when we are converting T to delta network, we got R1 is equal to R by 3. Means here when see, this is the case where all 3 resistors are equal. If all 3 resistors of T networks are equal, then all 3 resistors of delta network will be equal, and they will be equal to 3 times the one resistor. And here, say when all the resistors of delta networks are equal, then the converted T network will have a equal resistance, and that resistance value will be equal to one resistance of one network, one resistance, means like say for example R divided by 3, means 1/3 of a one resistance. Here 3 times the one resistance, and here 1/3 of one resistance, okay. And one more, dear students, I don't know whether you had observed or not in previous, if 2 resistors are equal, no, in a T network, when we convert that to a equivalent delta network, there also 2 resistors will be equal, but of some other value, okay. Say in previous numerical whatever I have solved, you can just cross check it, okay. If there are 2 resistors of T or Y are equal, and when we convert to a say another network, like say for example delta or pi network, then there also 2 resistors will be equal. And this resistance, if you see, this resistance will not be there. This resistance is, I will draw like this, okay, and this resistance R3 will be, this is R2 and this is R3, and this is R1, this is R. Hope this is clear. R will be as it is, this R will not be there, okay. And now say these 3 resistors are converted, okay. Say these 3 resistors are converted back. So just a minute, there is a data problem. Here say I have already found the resistance value. These 2 resistors are in series. Little bit I will just see, these 2 resistors are series, these 2 are in series, and these 2 are in series. Little bit I will reduce this once again. One is R, another one is here R, between these two we are finding R in, this is R, this is R, and here one resistor, here another resistor, and here third resistor. Right. So look at dear students, this resistor will go, these two resistors have taken in series because this is the network which I have drawn intermediate. These two are reduced to one resistor, these two reduced to one resistor, and these two are reduced to another resistor. Okay, because of that you will get 1, 2, 3 resistors here. Okay, so and this resistance I call it as say R4, this is R5, and this is R6. So and for your information, R4 is equal to, this is R4, R5, R6, R4 is R plus R2, and R5 is R plus R1, and R6 is R plus R3, and this R is 2.2K plus R2 is 733.33 ohm, so which will be equal to, it is 2933.33 ohm. Even all these resistances will be 2933.33 ohm. This is also 2933.33 ohm. So we have found R4, R5, R6, right? So now very simple, what I do, this particular network, it has a T it contains a T resistance here. I'll convert this T network, I'll convert this T network to a equivalent delta network like this, and this is another one, and I call this as, say for example, say resistance R7, this is R8, and this one is R9, this resistance is R9. Now calculating these three resistors, R7 is equal to, now we are converting T to delta, obviously R7 is R plus R plus R into R divided by the resistance which is not connected is this R5, and this is equal to, say R plus R, say I will directly calculate this, 2.2K plus 2.2K plus 2.2K into 2.2K divided by R5 is 2933.33 is equal to, it is 6050 ohm, right. Similarly now R8 is equal to, so R8 is this resistance, you can see here R8 is this resistance, and two resistances which are connected to it as R and R4. Okay, so this is this R and R5, R plus R5 plus of R into R5 divided by the resistance which is not connected is this, which is R, and this if you calculate it will be equal to, say it R8 will be equal to, R is 2.2K plus I is 2933.33 plus 2.2K into 2933.33 divided by, say the resistance is 2.2K is equal to, it is 8066.66 ohm. And similarly R9 is equal to, R9 is this resistance, two resistance which are connected is R plus R5 plus of R into R5 divided by R, and this also you will get equal to 8066.66 ohm, right. So we have found all the resistors. Okay, so we found this is R7, R8, R9. If you see dear students, this resistance will go, this resistance will go, and this resistance will go. Between these two I will redraw this, you can see I will redraw this network. Between these two you have only one resistor, that is here R in should be calculated here, and between these two resistors will go, and you have only one resistor whose name is R7, and now this resistance will go, this resistance will go here. Two resistors are there, R8 and R4. Okay, so both resistors I will find the parallel equivalent resistance, and I call that as a, say for example, R10. And here two resistors you will get R6 and R9, and that parallel resistance I call it as a R11. This is R10. So where R10 is equal to, R10 is R4 parallel with R8, this resistance R4 parallel with R8, and R11 is equal to, it is this R6 parallel with R9, R6 parallel with R9, which is equal to, so now R4 is how much? R4 is, yes, its value is 2933.33 into 8066.66 divided by 2933.33 plus 8066.66. say how much you get? It is equal to, say here 2151.11 ohm, and this is equal to, if you calculate this, it is also because the resistors are equal, you will get 2151.11 ohm, right? So now this network can be easily, the resistance from this network, the resistance R in can be easily found. R in is equal to R7 parallel with, okay, R7 is parallel with series combination of R10 plus R11, right? And this is equal to, R7 is how much? Say R7, the resistance R7 is, it is resist 6050 plus R10 is 2151.11 plus this also 2151.11 ohm, and this is equal to 6050. Okay, it is in parallel, here it is parallel, right? So is in parallel with, say both the combination if you add, it is 24302.22 ohm, and this is equal to, let us calculate, dear students, it is 6050 into 4302.22 divided by 6050 plus 4302.22 is equal to, it is 2514.285 ohm. So that is R in. You can see, dear students, even earlier also we had found R in, and so that R in was, it was equal to 2514.286 ohm, and this is obviously, so that is a error, so that much will be accepted. Thank you for watching.